Here's an example of finding the derivative by using implicit differentiation and also the quotient rule. I really don't want to do this right here because this example is rather confusing, especially if you are taking calculus 1 for the very first time. So we have the equation e to the x over y is equal to x minus y. We have to do implicit differentiation because y is isolated. It's not possible to isolate y right here, but it's okay. Let's put down d dx to show that we are differentiating this equation with respect to x. Here we go. The left-hand side has e to the x over y, so it's an e to the box. The derivative of that is just the same thing. So we have e to the x over y, and then we multiply by the derivative of what's in the box because of the chain rule. So x over y, we have to use the quotient rule. We are going to square the bottom right away, and then we put on the bottom function times the derivative of the top. Derivative of x with respect to x is just 1. And then we subtract the top function times the derivative of the bottom. Derivative of y with respect to x is dy dx. And that's what we're looking for. Continue, that's equal to 1 minus y, differentiating that with respect to x, we get dy dx. So we have it here and also here. I have a video just covering on the first step of taking the derivative. So go ahead and check that out if you are taking calculus for the first time, and if you think derivative is confusing, that video will be helpful. Anything after this is just going to be all algebra. I want to isolate dy dx. On the left hand side, we have a fraction, right? This over y squared. So I'm going to multiply both sides by y squared. And the right hand side, so I'll put it like this. So that y squared can cancel. But be careful, we have this times this thing, which technically I should put them in parentheses because we have to distribute this into the parentheses. And seriously, when you are doing this for the very first time, a lot of things are very confusing. All the notations are intimidating. I really understand that. We'll do it together, slowly, gently, calmly. Just relax. Okay, this times y, I can put y down first, and then we have this. Continue, minus. This times that, let's put on x, and then e to the x over y, and then dy dx. And then right here, remember we have to take this times y squared, and this is the time that we have to distribute the y squared. Do it backwards. So we have y squared minus y squared dy dx. We're making progress. Now, we want to put all the terms that has dy dx on one side and then the rest on the other. This right here has negative. I will keep it here. I will put this to the other side. This does not have dy dx, so I'll put this to the right hand side. Check this out. When I bring this to the left hand side, it becomes positive y squared, and we have dy dx along with this, so minus x e to the x over y, also the dy dx. On the right hand side, this right here stays, but I'm bringing this to the right hand side, so that will become a minus y e to the x over y. Now have a look. Both terms have dy dx, so we can factor that out. And I would recommend you guys to put that at the end. So here we have y squared minus x e to the x over y, and then we multiply this by dy dx. And that's equal to the right hand side. Now we have this quantity times dy dx is equal to that. All we have to do is to divide both sides by this and we'll be done. So, ladies and gentlemen, we get dy dx. This will be on the top. over, this will be on the bottom. So we have y squared minus x times e to the x over y. And this is pretty good, right? It's a pretty standard result for this kind of question. If you box this one right here for my class, you get full credit for it. In fact, we can continue this a little bit, because notice we have e to the x over y here and also here. Originally, we know e to the x over y is equal to what? X minus y. So if you continue, this right here is equal to y squared minus y. This thing is x minus y. And then over, this right here is y squared minus x, and this thing right here is, again, x minus y. Kind of nice. And then, of course, you can keep going, distribute this thing, so you are getting y squared minus xy plus y squared over, here we distribute this, so y squared minus x squared, and then plus xy. And finally, perhaps we can only combine this and that. So you can also say 2y squared minus xy over, that's right, y squared. Perhaps put this in the middle and then put this at the end.